Have you ever considered what makes a network communication truly work? Beyond the wires and wireless signals, there is a fundamental element that dictates whether information is successfully understood. It is the very core of what you are trying to send and receive. The data payload is crucial for transmission because it is the actual information or message being sent between communicating systems. Without an intact and correctly interpreted payload, the entire purpose of network communication, which is to exchange meaningful data, fails. It is the essential content that makes any data transfer valuable. Understanding why begins with realizing that all network communication relies on data packets. A data packet is like a digital envelope carrying your information across a network. It consists of two main parts, the header and the data payload. The header contains control information, such as the source and destination addresses and the type of data being sent, while the payload holds the actual application data. Its integrity is paramount because it directly represents the data an application needs to process, such as a web page, an email message, or a video stream. If the payload is corrupted or incomplete, the receiving application will not get the correct information, rendering the communication useless. When troubleshooting network issues, focusing on the data payload is vital. If an application receives data but cannot use it, or if it produces errors, a common cause is a malformed or corrupted payload. This could indicate a problem with the sending application, an issue during transmission like electrical interference, or an error in how the receiving application is trying to interpret the data. Verifying the payload's structure and content, often through packet capture tools, can reveal exactly where the data deviates from expectations, allowing you to pinpoint the root cause of communication failures. Furthermore, the size of the data payload impacts network efficiency and reliability. There is a concept called maximum transmission unit, or MTU, which defines the largest payload size a network layer protocol can handle. If a payload exceeds the MTU of a network segment, it must be fragmented, meaning it is broken into smaller pieces. This fragmentation process adds overhead and can increase the likelihood of packet loss, as all fragments must arrive for the original payload to be reassembled successfully. Efficient payload sizing can therefore reduce network congestion and improve overall communication performance. Ultimately, the data payload is not just a component of a packet. It is the very reason networks exist. Its accurate and efficient transmission ensures that systems can reliably exchange the information they need to function correctly. By focusing on the payload's journey and integrity, you gain a deeper understanding of network health and a powerful lens for effective troubleshooting.
If this helps you fix faster, like, subscribe, and keep debugging with us.